This session proceeds now with another paper submitted by our colleagues from Karlsruhe. We're really delighted to have that paper here. It's about a concept for the configuration of turnkey production systems. It's the group of Jürgen Fleischer who submitted that, and it's authored by Philipp Gönnheimer, Andreas Kimmig, Christopher Ehrmann, Jan Schlechtendahl, Jan Güth, and Jürgen Fleischer. We are looking forward to your presentation.
Hello, my name is Andreas Kimmig and I work at the Institute for Information Management in Engineering at Karlsruhe Institute of Technology, KIT. Today I want to present to you a concept for the configuration of turnkey-ready production systems. Current product life cycles are becoming increasingly shorter. There's also a demand for highly individualized products, but also the need to produce variants very cost-effectively. Young companies, especially in developing countries such as China, often innovate quickly but might lack the knowledge or capacities for scalable production. Now, when it comes to production systems, currently there are high expenditures required to integrate different components of different manufacturers from all over the world. The product design, as well as the production system design, usually is a sequential and therefore time-consuming process. Also, in trying to find optimization potentials, it can only happen by integrating certain steps along the value stream. To meet these challenges, we deduce a demand for a new approach to set up, commission, and operate turnkey production systems. In this approach, we propose that a turnkey production system is a composition of modules. Those modules are described in a certain way, and thus their compatibility can be validated and verified both using an online software tool, but also by testing and validating the actual hardware. We also propose a more integrated way of designing the product together with the production system, where changes in the product design lead to an accordingly different production system design, almost simultaneously. This idea stems from the project I40P. I40P stands for Industry 4.0 Turnkey Production System Platform, which is a collaborative project between German and Chinese industry as well as university partners, namely KIT, Bosch Rexroth, Schaeffler and Schunk on the German side, as well as Tongji University, Shenyang Machine Tools, Microcyber and ITE on the Chinese side. The project itself is structured into 5 components. Those are turnkey, which focuses mainly on the architecture of the platform. Design, which looks mainly into how the product design and the production system design is intertwined. Business, which develops business model concepts and tools for the different stakeholders of the platform. Collaboration, which focuses on the communication and collaborative aspects of the stakeholders. But also Demo Validation Center, in which hard and software can be validated, but also showcased. So what is the goal of this platform? Well, it's threefold. First, a customer of a turnkey production system should be able to configure an optimal solution for his or her given product. Second, the commissioning will be completely automated by using plug-and-play solutions. And third, the operation and monitoring of the turnkey production system is enabled via the platform. Now I will give you an overview of the simplified framework of our process. We start on the left-hand side with the customer, who has a product that he wants to produce. The customer uploads the product description, for example a CAD file, to the platform. The product then gets analyzed by the platform's Feature Extractor in order to see which process steps are required. The Turnkey configurator then uses this information to select machines and component modules accordingly. We therefore use a database in which all modules are saved in an easily searchable description format. The Turnkey builder then generates a visual representation of the selected Turnkey production system configuration, which can then be reviewed or changed by the customer. After the customer is satisfied with the result, he can then order the production system directly on the platform. After setting up the physical system, the platform enables machine communication and monitoring functionalities. Now I want to go a little bit more into the details of the individual steps, starting with the feature extractor. On the left, you can see the housing part of a shunt gripper, as depicted on the lower left. The feature extractor analyzes the CAD and then creates a file, in which all recognized features and feature parameters are listed. An item on this list can be, for example, one of the boreholes together with its diameter, depth and position. The analysis for this can be done, for example, by a simple integrated CAM software. But there are also other approaches using rule-based but also machine learning-based algorithms. One of the main challenges here is the recognition of multiple overlaying features, because they are not that easy to differentiate. When using this feature list, we allocate the features to suitable production processes, such as milling, drilling, and so on. Keeping in mind the parameters and thus the required tool sizes, we can then sort and combine the individual required production processes. Resulting from the algorithms described in the previous slide, we get somewhat standardized product information models, as well as product process information models. These are basically our requirements. Not all, since there are other factors that have to be considered, like customer requirements, tolerances, and so on. But to keep it simple, we will just focus on those for now. On the other hand, we have a database containing the whole catalog of possible machines, tools, and components that can be used for the manufacturing process. Those so-called production modules are also described with a somewhat standardized information model. Now we can match the process requirements coming from the product side on the left with suitable production modules on the right. A very simple example for a match like this might be that the dimensions of the product are smaller than the workspace of the machine. Here we can see how this matching process between the product and the processing, as well as the machines and tools, looks like in a little more detail. In green, we have the dependencies for the finding of a suitable machine. The blue connections are the dependencies of finding the suitable tools. And in yellow, we guarantee that the machines and tools are compatible and use the same interface. As you might imagine, this can result in a lot of options on how you can build your product. Thus, the result of the algorithm can be a big list of a lot of production system configurations. This is where we have to sort and rank the different configurations using the previously mentioned customer requirements. Those requirements can be, for example, efficiency, quality, or quantity related, but also keeping the customer's budget plan in mind. After sorting and ranking the configurations according to the customer's preferred target criterion, the algorithm then presents the 3 best configurations. This has the advantage that for further calculations, only a few solutions have to be simulated. An integrated engine then visualizes the production system configuration as well as the linking sequence on the web platform, so that the customer or consultant can validate and/or change the production system layout. The customer can also exchange single components or machines he or she already owns or rather sees more fit. Here we see the visualization of an example configuration using the open source VR engine PolyVR. This production has a source on the left with the raw material and the sink on the right. In red we have the outlines of the clearance areas for the individual machines or stations, and in blue we can see the value streams or transport paths. The machines are positioned in an automated layout proposition based on the underlying processes as well as the selected machine parameters and the equipment. The customer also has the option to use his or her own shop layout as a further requirement for the configuration process, or customize the layout later on. The use of unified information models enables an easy setup of the machines in production through self-description of the hardware modules. Having created quasi-digital twins on the platform can also be used for the coordination of production processes using a workflow engine and hence making production monitoring and production control possible. In summary, we observed a demand for production systems that need to be set up, put into operation and be reconfigured in a quickly fashion, due to short product life cycles and increasingly individualized products. This demand is especially prevalent in young companies in the product development field, because they often don't have the know-how or the capacities. The presented approach shows a methodology how production systems can be systematically configured and put into operation quickly. Future research will focus on the integration of operating data into the developed information models, but also on detailing and further validating the presented configuration approach. Thank you very much for your attention.
Thank you very much, Andreas Kimmig, for presenting and submitting that paper about configuration of turnkey production systems. We are now establishing the connection on the live Skype call to Andreas Kimmig.
Hello?
Hello, Andreas Kimmig. Can you hear us?
Yes, I can hear you.
Thanks for joining us. Thanks for the paper. Thanks for the presentation.
Thanks for having me.
In the context of your paper, I'd like to discuss the different cultures that you consider in the project. We have seen that you're working in a cooperation between Germany and China. So can you comment on how these different business mentalities will welcome the innovations that you do?
Yes, sure. What we saw, what was our experience, is that the German business culture might be a little bit more, let's say, conservative. They want to think about stuff, they want to plan in advance. And the Chinese mentality is a little bit more like, do it, and if it fails, it doesn't matter. We do and do and do, and yeah, we keep on doing.
Okay, thank you. And also I have noticed that you are distributed from Germany, from Karlsruhe, and also for the Turnkey University. So I reckon the project which is behind this research also spreads across the labs at Turnkey University and Karlsruhe lab. Can you say something more about the implementation or the demonstration of this project that you are having there?
Yeah, of course. At Turnkey University, there's a laboratory. It's called AMTC, which is kind of associated with WBK of Professor Fleischer. And they have several machines, such as DMG Mori, an EMAC V2, and Bauchi, and some other production systems. They have lots of robots, so we can actually, try out our platform and put it into motion,
okay.
As well as in Germany. Yes.
Okay, thank you. So, and in this research, a lot about the usability of this configuration system is about is related to the visualization of what goes on in the architecture. What did you encounter when developing the visualization of this tool set?
It was actually not that easy to implement our visualization on an automated basis, because we had to get all the step files from all the production systems, which most suppliers don't really give us all the information of, and we had to convert it automatically, and then we had to load and do an automated layout planning, and that was not that easy.
How do you think you can tackle that in the future?
We are currently working with an automated approach where you could integrate all modules that the suppliers will give us in an automated way, and we have an easily readable format for that. So we don't work with step files. We previously changed the format directly.
Do you have do you have the elaboration of the IP and the ownership and the copyright thing behind the data? How far did you get there so far? That's always a problem.
We currently like it to avoid this topic, because especially with China, it's currently not that easy to work with the data security, because companies have a lot of thoughts about how stuff works in China, so they try not to give too much information out, and the Chinese side as well doesn't want to share too much information. We're currently working on concepts how we could tackle this, but we didn't get too far on this topic.
Okay, so there's still a lot of work to do. Can you tell us a bit about what you're planning to do based on the research that you have in the paper and in the presentation in this conference?
Can you specify exactly what you...
So you're in the project context of a funded project right now.
Yes.
So what is a plan that you have with the turnkey configuration system that you have developed right now?
At the moment, we are trying to get other companies involved so they can check out our demo cases, try it out for their own products, and they can see if it's something for them, and if they want to supply us with their modules or their products they want to sell or they want to implement inside of the production systems, and also in our platform. So we get some feedback, and if they want to change something, or if they want to develop something for themselves, they could get in there.
That is interesting.
Yes.
Do you have a business model to commercialize this already?
At the moment, we are working on that. We are actually working in a whole task of this project on developing business models for different stakeholders on this platform. So the guys who sell the products or sell components get their own business model, as well as the platform itself.
Okay. Yeah, so thanks for sharing these insights with us.
Thanks for having me.
Andreas, Kimmig. Thanks for being with us. Thanks for being available for this live question and answer regarding your paper. Goodbye, and we see you next time.
Thank you. Bye-bye.
Okay, goodbye. So this was the presentation and question and answer for the paper entitled Concept for the Configuration of Turnkey Production Systems. It is authored by Philipp Gönnheimer, Andreas Kimmig, Christopher Ehrmann, Jan Schlechtendahl, Jan Güth, and Professor Jürgen Fleischer. Thanks for doing this presentation.